All right, so this is question 2 in the week 6 print handout, and it says the 5-digit number 5A816 is divisible by 24. So we need to find the sum of all possible digits A. And so basically what we're doing is we're trying to find what values of A make that 5-digit number divisible by 24. So first what we have to do is we have to prime factorize 24. What are the factors of 24? And then we can say, well, if our 5-digit number is divisible by all of those factors, then it's got to be divisible by 24 as well. And to do this, we're going to have to use some of our divisibility rules, which I'll go over. So the factors of 24, well, 24 is equal to 8 times 3, and 8 is 2 times 2 times 2, so it's really just 2 to the third times 3. So if 5A816 is divisible by 2 to the third, and then also divisible by 3, well, that means it's divisible by 24. So how do we figure it out if it's divisible by 2 to the third and then also by 3? Well, 2 to the third is 8, right? And there's actually a really easy divisibility trick for figuring out if something is divisible by 8. So the way this works is if the last 3 digits are divisible by 8, then the entire number is divisible by 8. So in this case, the last 3 digits are 816. 816 is divisible by 8 because 800 is divisible by 8, and then 16 is also divisible by 8, and when we add them up, they're also going to be a multiple of 8. So since these last 3 digits are divisible by 8, we know that the whole number is. So for example, if we had the number 2, 3, 4, 9, 0, 6, 4, we know that this number is divisible by 8. We don't even have to divide it or look at any of these earlier digits. Just by looking at these last 3, we know that 64 is divisible by 8, so the whole number must be. And the reason for this, if you want to know, is because 1000 is divisible by 8, right? 1000 is equal to 5 to the third times 2 to the third, and 2 to the third is just 8. So if 1000 is a multiple of 8, well, that means that no matter how many thousands we have here, it's all going to be divisible by 8, so we just have to verify that the last 3 digits, the remainder when you divide by 1000, is also divisible by 8. So that's what we're doing here. So this number, 5A816, we know regardless of what A is, this number is divisible by 8. So now we just have to make sure that it's divisible by 3. So the divisibility rule for 3 is that if all the digits add up to some multiple of 3, the whole number is a multiple of 3. So in this case, we have 5A816. Well, 5 plus 8 plus 1 plus 6, that's equal to 20, right? We have 7, yeah, it's equal to 20. So we have 20 plus A is the sum of these digits. And so we want 20 plus A to be some sort of multiple of 3. Now, looking at our multiples of 3 that are greater than 20, we have 21, we have 24, we have 27, we have 30, but we can't get to 30 because A can't be 10. So these are the 3 numbers that we can get to with A being, a digit. So A would have to be either 1 to get to 21, or A could be 4 to get to 24, and then A could also be 7 to get to 27. So 1 plus 4 plus 7 is 12, and so the sum of all possible digits of A is going to be 12.